Hello everyone, welcome to Learn Overflow. In this video, we'll discuss another little problem that is the binary level order traversal. This is a medium level problem, and we'll understand what this question is saying us to do and how in various ways we can solve this question. What should be our thought process behind solving a question like this? So that will be all our approach in this video. Also, at the end, I will I will give you an exact solution for this code, and then we'll understand how that solution actually works according to our thought process. So that will be all in this video. It says like we are given a root of a binary tree, so we will be given this root, and then we need to return the level order traversal of the nodes or the nodes values, okay, from left to right. So if for every like the we need to give the explain it to in a moment that we need to return the level order traversal of the nodes and from left to right and then level by level. So what it exactly means is so this is at level 0, fine. So this root at level 0, and then all of these childs whatever we have from here are at level 1, okay. Then all of the childs, maybe 9 had some other childs also, okay. So that's also possible. So we need to put all those other childs in another level. So these are the different levels you have. Say after 15 there are other nodes as well. So those are also other levels. Okay. So we should go ahead with that. See how the answer goes is this given like 3, 9, 20, and then null for 9, and then 15, 7 is given. So how they're returning 3 being one of the like is a 2D list. So one of the sub list, and then 9 and 20 because they are in the same level, we are returning that, and then 15 and 7 is also in the same level, so we are putting it in one sub list and returning that as a whole 2D sub list. Okay, so that's the idea. So let's take a small example like to understand what they're exactly saying. Say there are nodes like this. Okay, I'm just not taking the values but rather just marking the nodes. Okay, it may happen that we come across something like this, fine. We come across this, and it should be, we should remember that we should go ahead from left to right. Okay, the order is always 15 is on its left and 7 is on its right, so that's how we added them in the sub list, and 9 is left, 20 on its right. So in the sub list you can see the exact their positioning that will be going from left to right. Okay, so if we go ahead in a list like this and say we have a list like this, fine, and there you have a list like this, fine. So if our list looks like this, let's understand how this will happen. Our first element in our sub list, like first sub list will contain this, fine, and then we'll go ahead with this elements from left to right in our level 1. Then this will be our level 2, fine. Level 2 in the sense it will be another sub list like this, and then it will go ahead with this, fine, within our levels, and then we will go ahead with the last element, or the one, 2, 3, and then fourth level. This is the 0th level. Okay, so in this format we should go ahead. So once we can see that this is not like we are not going in a depth of each like each of the particular way we have, okay, each of the particular branches we have, we're not going in the depth of it, we are rather going each of the levels at the same time. So what can be our app? The first approach you can see is we use BFS technique, right? So, like breadth first search. So in the breadth first search technique, we already know that this is the way we actually traverse our particular tree. That we'll go ahead with the root, then go on its left, on its right, then left of the left, and then right of the left, then left of the right, then right of the right. So this is the format we go ahead in BFS technique. So if you're going ahead with a BFS technique, so you already know that this will be our particular format of, this will be a particular way to move into our list. Okay, now so and for that we will simply have a some kind of count that was the current level, and we'll keep on adding all this. Okay, but if we're like also like to be honest, I will be going ahead as a solution in the BFS technique. But if you're thinking what is the DFS approach, but the DFS approach you can think of, you need to modify something. Modify in the sense you will be going in depth of a particular like particular branch, right? So when you'll be doing that, you need to keep a note in the sense that at each levels you have only what we have the value, you have the left, and you have the the tree node values. Okay, and you need to modify this tree node with maybe a subclass, maybe something else, or maybe another variable with valid with each node. You need to add the particular level the level, just add the particular level, fine. With each tree node, like modify and create another class, and in that class take the tree node, and with the tree node take the levels, fine. If you do like that, then you will keep traversing on the left, and you know the what this current level is. Okay, once it has a current level, you can mark them, and once returning back and going the other level, you can add in the particular sub list you have, and you can mark. Say you just went in this particular example from 3 you went to 9, and 9 is at level 1, you mark 9, like added 9 to the second sub list, and then moved back to 3, you found 3 is already there, then move to 20. 20 is in sublist like at level 1. So you took like array list dot one, like get 1, 1 being 0, 1, 1 will be its value, right? Its positional value to small sublist you have over here. So in that add 20. So add 20, and then on third level, like on second level, you will add 15 and move back, and then add 17. This is the way if you go ahead with the DFS, depth first search method. So if you're going at depth of search, you need to keep a note of the particular value you have, that is the height of the, like what is his current height, what is the current level you are at. So that's an additional note you need to keep for each node. That's okay, that doesn't make a big difference for you, but in this case, like in the BFS technique, why we're going at the BFS is the common technique that is going in this format. Like when is we're going in level order traversal, BFS is the one that is already going in this format. They are the one following the format we want to use. Okay, we just need to keep a track whenever our particular level is changing. We need to keep a track of that. So that's our BFS. So I'll simply go ahead to the BFS technique. We'll check how we'll first add this route file to our main queue. Like for BFS, you remember we use a queue, and we keep on traversing the queue, and we will add all of its child nodes in its another queue, fine. Say we have a queue that is storing the root nodes, fine, and we have a queue that is storing all of the child nodes, fine. So as soon as we find all the child nodes, we keep adding them in our root node, in our child queue, and once our main queue becomes empty, we add, like for each of the values in our main queue, that is the queue containing the root nodes, right? So once we come across each of the node, we add them to our list, like the sub list. We keep on adding them to our sub list, and ultimately add them to our main list. Okay, and then move on to the then make our child node as our current queue, and then keep on adding like its child values in its child nodes. So we'll understand what I exactly mean in this format. But this is an approach that I use personally. Like I will use in this video. I will explain this. Fine. So that's our whole code is all about. We'll understand what exactly we did. So you can say it's like a 1 MS solution. Like just now, I again did it as a 2 MS solution, and you can see it's more or less the fastest solution you have, or you can end up in a 0 MS solution as well. So let's understand what this code is all about, like how we solve this. Okay. So what exactly we did, we took an 2D array list, the one which we need to return. Okay. And then we check if our root is null, like that's being our case 3. Okay. If our root is null, we simply returned our answer, being that is the 2D array list we have over here. Because it's null, so we don't need to do anything. We just return it. Now, what exactly we did? We used two queues, like first a queue this will store all our root elements, and then a child. This will store all our like child elements of the current root. Okay, and in that we added its root being the current root we have over here, that is the 3. Okay, the main root of the whole, the root we have given over there. Okay, so what exactly we did further, we took in sublist will be the one which will be this small list. Okay, so that's the sublist we are creating over here. Fine. Now what we try to do, we just check while q dot size greater than 0. Current q size is 1, we added only one element. So q dot size greater than 0, that is the q size is 1, this is greater than 0, we'll move forward. Fine. What we find further, we find that we are doing q dot remove. Okay, q dot remove, that is it will remove us the topmost element or the first element we have. Currently we have only one element, so we got 3 before. Fine. But usually only do q dot remove, you will find it on this format. Like if there are 9 and 20, q dot remove will give us 20 because it's a linked list, and linked list will be whichever added first will be there in the first. Follows the FIFO format. So 9 will be added first. How? We'll see in the next slides. So first we got the current is our this node. Okay, the root node we have over here right now. Now we simply added sublist. This is sublist forming this small list I said. Simply added sublist dot add current val. Fine, we got our value in our sublist. Now we're checking if the current dot left is not null. If the left value is not null, we did what? We did the child node, that is the child tree or the child nodes we are storing in our another queue. We did child dot add current dot left. We just added the current dot left to our child, and then if our right is also not null, we added child dot right in our child dot add our right node. Okay, so see, we are first adding the left, and then we are adding the right. So in this case, what will happen? It will always keep that check in its own. Okay, that once we are done with the current node, like it will be first in first out format. So the left is getting in the first, so that will be the left to right format we want. Okay, say we wanted a right to left format, so we should go ahead with the current dot right to be added first and current dot left to be added next. So that would give us a right to left format. Fine. Now further, so this is the one we are just adding to our child queue. So this is another queue we have. Fine. Now what it did, if our queue size is 0, that is after removing our current element from the queue, if we find the size is 0, okay, for us in this case, after removing the main root, which we had only one, our queue size became 0. Fine. So we are getting into this part. What are we doing? We're doing answer being our main 2D list we had, which will be our final answer, return answer. So we just did answer dot add sublist. Sublist was the one we are creating to add all the sub elements we have, or the current level elements we have. So answer to add sublist will be adding a whole list into our like creating it a 2D effect or into our current list. Fine. Now further, what happens? We just made q pointing to our like this q the q linked list we have is just started pointing to our child, and we made child to be a new linked list. Fine. And also we made sublist to be a new linked list. So that's the stuff we did over here, and then we like q got like new values. So q got new values like 9 and 20. Again we'll get into q greater than 0. Yes, and we found that current is 9. We added its value at 9 to our now sublist, so we added this value over here, and then we find its left. We find its left is not, we're going to add anything. Right is now we're going to add anything. We found q size 0. No, it already contained 20 in it. Okay, we'll wait for that. So next we again, like we find q size is 1, which is greater than 0 now. Now we find the current is 20. So we add 20 to our list, sublist, 20 being added. Now we add current dot left is not 15. So we just add child 15 to it, and we add 7 to our child. Then we find q size now becomes 0 because we already removed the last element. And then we again pointed it to the child node, the child being the 15 and 7. This particular queue we have is pointing to that, and we initialized our child and initialized our sublist. So we just got new values over there. And ultimately, when the whole list, whole loop gets over, we simply return our answer. We got our answer, being answer was created at this position for each sublist is created. Fine. So that's the main idea about the whole about this question, guys. I hope I can make you understand how this particular question works. If you want, you can comment down any of your doubts. I'll be happy to help you out. So that's all about this video, guys. Thank you all for watching this video. Hope to see you soon in my next video as well. Thank you.